In this section, what we're going to do is take a sum, or take a sample, and compute its sum. So that's what we're going to be looking at here, is draw a sample, compute its sum, and then we'll be looking at the sums. So take, for example, roll 10 dice and compute their sum. So the sum will be anywhere from 6 to, let's see, 10 out of 60, actually 10 to 60. And you repeatedly do this over and over again. Do this over and over again. For a total of 100 times. Then what you'll get is something that's normal with the following information. We'll have a mean remember, mu of x is the mean of the random variable x. And the standard deviation is the square root times sigma sub x. In the case where I'm rolling dice 10 times, n would equal 10. We could say if I did this 100 times, I might have a data set that would look something like this. And each of those entries would be some value from anywhere from 10 to 60, depending on the sum that came up. So these are the things that we're going to be doing the theory on here, are these sums. Now, if you want, when you do something like this, I have sort of not done it, but I suppose you could do something like this, and you could do something like this to indicate what kind of standard deviation, what kind of mean you're using. But these will be the formulas that we'll use for the two things that we have. And the z, that's what our z-score will look like. Here's our first example we're going to do out of the textbook. An unknown distribution has a mean of 45. So this here, that'll be our mu sub x, and a standard deviation of 8. That'll be our sigma sub x. A sample size of 50 is drawn randomly from the population, so we'll call that n. Find the probability that the sum of 50 values is more than 2,400. So let's start here first. Let's get the mean of this. And so that's going to equal n times mu x. The n is 50. Mu x is 45. Let me grab the calculator, get that number. And then the standard deviation so we have the square root of 50 times 8. I get 56.5685. Find the probability that the sum of the 50 values is more than 2400. More than, that's greater than, so we're going to have something shaded to the right. So let's take a look here at a picture. Okay, this will be my mean here, the 2250. And we want to know if it's more than 2400. So we're looking for the area inside that tail end. Let's go ahead and calculate the z-score. We're looking at 2400 minus n times mu x, that's 2250, and divided by 56.5685. And let's go ahead and calculate that with the machine. Remember, you want to limit these to 2 decimal places. And then from here, you can either look up this white space out here, which is what I am going to do, and then subtract whatever you get from 1 to get this other side. The table gives me 0.99598. So the other one then, 1 minus 0.99598 equals, and final answer 0.00402. I suddenly realized I never even drew a standard normal distribution. I'll do that so that I make the problem complete like the rest of them. This was supposed to be 0 up to 2.65, and of course the area, there's the area we found using the table, and then over here 0.00402. Here's our next example. A recent study reported the mean age of tablet users is 35 years. So there's mu sub x. The standard deviation is 10 years. So there is sigma sub x. The sample size is 39. There's our n. What are the mean and standard deviations for the sum of the ages of the tablet users? What is the distribution? Okay. So we'll start with this. The mean of the sums is going to be n times mu sub x, which is 39 times 35. The standard deviation of this is going to be the square root of n times sigma sub x. That'll be the square root of 39 times 10. The type of distribution will be normal. As long as the n is greater than or equal to 30, we can be pretty certain it's going to be normal. Close enough anyways. Let me go ahead and get these calculations. I would write that out to 4 decimal places, but there are several 9s in a row and only 2 come out. So if you wanted to know that it's up to 4 decimal places of accuracy, I will include that. Now normally the way this is thought of is a sample is chosen and then its sum is computed. So that's what is the nature of part B. Find the probability that the sum of the ages is between 1400 and 1500 years old. So let me get the information in here. Our mean is 1365. And we want to see if we're between 1400 and 1500. All right, well, let's get the z-scores. Start with the 1400. This one over here, that'll be z equals 1500 minus 1365 divided by 62.45. Let me get these numbers. Now let me draw the standard normal distribution. And as before, I will get the areas in those white regions and subtract them from 1. Now that I've got those values, what's in between, I will subtract away from 1. 1 minus 0.71226 minus 0.01539. So we end up with a little over 27%. I believe there was a part C to this question. Here it is right here. Find the 90th percentile. So this one you start sort of in the reverse. So we'll start first with this. So we don't know what the z value is, but I do know that there's 90% of the area here. So we want to go in there and look at closest we can get to 0.90 in the table. Let me go ahead and pull it up. I'll go to the positive side because you know it's going to be on the positive side. And let's see where we're at. 9. Right here we are, between these two values. All right, I have the relative part of the table that I want. These are my two values trapped between those two and this. So 1.2, 8, and 9. So the z that I'll pick is 1.285. I always take the halfway between. So let's put that in there. And now let's go ahead and try to solve for the sum. So what we're going to have here then is z is going to equal the sum of the x's minus n times mu x all over the square root of n times sigma x. And where were these things? The mu sigma x was 1365. And down at the bottom, we had 62.45. I'm just going to check real quick to make sure that number is right. Yep. Come back here. And to help facilitate yourself with the cross multiplication, I'll put that side over 1. So I will cross multiply those two things and these two things. So on one side, you'll have the sum of x minus 1365 is going to equal 1.285 times 62.45. To solve this, to finish it off, we have 1365 to both sides. So it looks like 1445.2825. That will be our 90th percentile. Here's one last example. Once you have the formulas down, it's pretty straightforward. Here, they give us the mean of the random variable x is 8.2, and the standard deviation is 1, and sample sizes, that's n. So when you're dealing with this, you want to make sure you're working with all the same units. Notice all these things are given in terms of minutes, but down here, they're giving it in terms of hours. So I'm going to convert the hours to minutes. Everybody knows that there's 60 minutes in an hour. So 7 times 60 will give us 420 minutes here. 10 hours is 600 minutes. Well, let's go ahead and get the mean of this distribution here. That's n times mu sub x. The n is 70, and the mu sub x is 8.2. Sigma is going to be the square root of n times sigma sub x. Square root of 70 times 1. Well, that's easy enough to do. All right, well, part A, we want these sums to be between 420 and 600 minutes. Now ours, to get our, well, this is where they're going to be the middle of my So let's get these z-scores. I think I already have one here, started. Let's see what we get for that. That's this one over here. This one over here is 600 minus 574 divided by 8.3666. Now, this z-value is way off the chart. So realistically, I bet you this wasn't actually where it was. This is way, I mean, this thing is way over here somewhere. And it's so small. This number is nowhere even possibly close to being on there. So to be honest, the area that's in the region from here on out, you can just ignore it. It's completely negligible. Maybe we'll have something to work with over here. Here I get 3.11. That means there is actually going to be area out here, but it's going to be very small. So here's a picture on the standard normal distribution. We have 3.11 is way out there. Even that's not going to be much of anything. So we just want that area there. You can look up negative, well, actually I didn't want to put shading, but it's essentially shaded all the way off to negative infinity. So I can look up negative 3.11 in the table to tell me what that area is. Or actually, I think I can just look up 3.11 directly and forget about looking up that white area. Sometimes I forget what the easiest way to do things are. Just go in your table and look up 3.11. And it looks like we're just a little over 99.9% for our final answer. So it's a virtual certainty. For part B, let me see if I can find what it was they asked for that. We want to find the 84th and 16th percentiles for the sum of the sample. So let's take a look. They should be quite similar to each other, because when we start these problems, we always look to the standard normal table for this information. So when we have this, here's what we're looking for. Here's 0. We want a spot here. I don't know, let's call it, it's a z value. I don't know what it'll be. And over here is a z value. And what we want is 16% here, and we also want 16% here. That way what I'll have here is, this will be the 16th percentile right there, and this spot over here will be the 84th percentile. So let's first start and find on the table what negative value will give me 16% to the left. So I'm looking for as close as I can get to 0.16. Here's 0.1609. Here's 0.15. So I'm straddling two spots here. Let's grab them. All right, I've pulled in the sections for the table that I want. We want to go to 0.16, so it looks like we're between negative 1.0 and this one over here, which is negative 0.99. So I'm going to use z equals negative 0.995. And then let's put our an equation then. So z, if you recall, equals this stuff. Let me see, the n times mu of x we had up there somewhere. Let's see if I can, 574. And on the bottom, square root of n times sigma of x was 8.3666. And this is going to equal negative 0.995. So I'll put that over 1 and do the cross multiplication. For some reason I copied that down as a 5 instead of a 6. And then add 574 to finish it off. That looks like 582 point. Careful, careful, very careful. Notice I forgot that negative there, so be very careful. So when I go to do it on my calculator, so there's my 16th percentile. Now you could, knowing what the median is, or the mean of this distribution is not 0, the other z-score is going to be on the same distance, but on the other side of the mean. What I'm saying is, I'm going to end up adding 574 plus 8 point something. You'll see what I'm talking about when we get there. So we have one, but let's just go ahead and do it directly. Now you can do this. We had, what was it, negative 0.99 was that score. So let me put that. That means this guy over here using symmetry is 0.99. So when you're doing the other one, here's what's going to be different about it. You're going to have the sum of x minus 574 will equal 0.99 times 8.3666. And the numbers will be exactly the same. I think these are more decimal places than I really wanted, but I guess I'll just put them for now. So then our 84th one is going to be 582.282934. This is the 16th here, and this is the 84th.